Okay, so the empirical rule is a pretty big deal. It leads us into something we're going to be doing later on. But suppose you have a symmetric distribution that looks something like that. Notice that later on we'll get into the actual normal distribution. This is not necessarily normal here. This is any symmetric distribution. Any of them. So if it looks like this, remember this is a picture of your histogram. If your histogram looks like this will work for you. Here's the game. Bam! Here is the mean. Yes? Now, for what we're doing, you're like, Groom, is it the population mean or is it the sample mean? Well, here it's technically the population mean. And then we're going to go over one standard deviation on either side of it. And in one standard deviation, 68% of the population are within one standard deviation of the mean. By the way, that's most of us. You with me? You mean IQ-wise? Correct. You mean height-wise? Sure. You mean whatever-wise? Sure. Wait, Mr. Groom, in some of my life, I'm a weirdo out here. I know. So I'm a weirdo out here. True. But most of the time, you're in the middle, bro, with everybody else. Are you with me? Now, if I go out 2 standard deviations or -2 standard deviations between here and here, approximately 95% of the population is within 2 deviations, we say, of the mean. What if we go out 3, though, Groom? Well, there's not much out here anymore, bud. Within 3 deviations, you will see approximately 99.7%. Okay? Now, why do I care about that? Well, here's why. Let's say that you, sir, are out there, whatever, you're on the dating market, and you know that women average 64 inches tall in the U.S. of A. But DA is taller. I'm well aware of that. There you go. And the standard deviation in the U.S. of A for women is approximately 2. Come on, stupid. Are you dumb? It's approximately, I was going to say it is 2.5 inches. I don't really care. Okay. Meaning here's 64 inches. Here's 66.5 inches. Bam. Here is 69 inches. Bam. Here's 71.5 inches. Bam. If I minus going this way, it's going to be 61.5. Bam. That is 59. And that is 56.5, I believe. Not. Yeah, correct. Duh. Yeah, nice. Now, Groom, what percent of all U.S. women between 61.5 and 66.5 inches tall? And the answer is about 68%. Why? Because they were within one standard deviation of the mean. Okay? Now, between 5'9 and, what was that, 4'11, that's 95% of the population. In the U.S. of A, between 5'9 and 4'11, that right there constitutes 95% of the women in the U.S., somewhere between there. And you're like, dude, that makes sense, Groom. You don't see a lot of chicks taller than 5'9", Groom. I'm well aware of that. Let's say that you were in the market to date one of them, though. You know what I'm saying? You're like, Groom, they've got to be taller than 5'9". Bam! Okay, Greco, cool. I'm right there with you, bud. I'm right there with you. That's kind of Mr. Groom's always been his wheelhouse. All right, there you go. It's taller than 5'9", bud. What percent taller than 5'9"? I don't know, but I bet we could figure it out. Well, which is 60. I'm going to go ahead and write it 69 inches just because that's what we're in. And you're like, Groom, how am I supposed to know? Bro, I got you. So remember, within 3 standard deviations. Boom, boom. This is 99.7%. That means that 0.3% total are out here and out here. But Groom, what percent's up here? I'm glad you asked, sir. What part of symmetric did you not grasp? This is 0.15%. How do you know that? Well, think about it for a minute, bud. We got this. Because it's symmetric. So half goes up there and, wait for it, half goes down here. You with me? So only 0.15% of the U.S. population of women is taller than 5'9". But how can that be? I know several of them. Yes, and how many you know that are way smaller than that, or way in between than that? Yeah, a lot. Yeah, a lot. Okay. Remember, we, a lot of us, have people in our lives who are, certain things. So around certain people, I feel brilliant. Okay, I feel brilliant around them. I'm like, boy, you're kind of dumb. I got a buddy that always tells people, Jay's so smart. He has a bachelor's degree. And he goes, this is how he always says, he has a master's degree. And he even has a bachelor's degree. I'm like, bro, it's backwards. He's like, are you sure? I'm like, yeah, I'm sure. Yeah. And so when you start talking about things like that with him, he's kind of like, okay, I feel kind of dumb around. I feel smart around these people. Other people I get around, I'm like, boy, I'm kind of a dumbass. I'm not very smart at all. Other people, I'm really tall around. I'm really short around, whatever it happens to be. Yes. And so we, a lot of times, in certain situations, again, we find ourselves in situations where we're like, oh man, everybody's tall in my life, right? And then you move around and you're like, wait a minute. Okay, yeah, in my close circle, I've got a lot of tall people in my life, okay? But as soon as I get out of there, oh yeah, everybody's just average. That's true. Or, hey, these people are really smart, people are really dumb, whatever. But generally speaking, yeah, there's a bunch of average floating around out there, okay? So just always be aware of that. Don't get all weirded out. Well, I have a lot of tall friends and so forth. I'm the shortest kid in my family, and I'm 6'7". Holy cow. But anyway, you know what I'm saying, right? Just kind of keep that in the back of your head. Great. What about this? What if the average... Oh, no, hold on. What if the coyotes in Oregon, average 72 pounds? I don't think they are, but let's just pretend for a moment. And the standard deviation is 6. Beautiful. Awesome. And it's symmetric, of course. Whee! So, of course, you've got 72, you got 78, you got 84, you got 90. Nice. And going this way, you're minusing, so 66, 60, and, of course, 54, right? And if I asked you what percent are between 78 and 84, you'd be like, well, how am I supposed to know? Okay, calm down. Within 1 deviation is 68%, yes? Within 2, it is 95%. If I minus those, I get 27%. Well, that's the total is between here and here is 27. So what do I want? Oh, I would like half of that. So I get 13. Well, damn it. 13.5%, 13.5%. Now, when I was a kid, I saw this kid do that. One person do this one time, and it always stuck with me, but it's always annoyed me too. Are you with me? It's always, I like it, but I hate it at the same time. Some people really dig it. Some people don't. I'm going to show it to you. If you like it, good for you. If you don't, then don't. 68% in the middle, half on either side. Yes? We just did this one. We said this is 13.5%. We said this is 13.5%. Well, now from here over is 50. True that? And so if you got 34 plus 13.5, you get 47.5. And if you minus that, you get 2.5%. What is this happening? Yes. That's exactly right. That's exactly right. No, hold on. That's 2.5%. Okay, hold on. Okay, so that's 1 deviation, 2 deviations. It's a total of 2.5 on the outside of that, but let's keep going. We know that this is, we know that's 99.7. So 99.7 minus 95 is 4.7 divided by 2 is, so 2.35, so 0.0235, 0.0235. And then if you do this, you will get the last one is 0.015. No, it's not. 0.0015. 0.0015. Let's see if that's true. So again, you get 0.34 plus 0.135 plus 0.025 plus 0.0015. Mr. Groom, you suck at math. I do. Let's add this up first. So 0.34 plus 0.135 plus 0.0235. There it is. It's 0.00, so minus 0.5. How about that? So 0.0015. That's what I wrote, but I don't know why it didn't work. So I was right the first time. Anyway, so a guy I knew used to have this written down on his paper somewhere. And he didn't memorize it. This is too much work for me. I just don't care. So if you said, hey, I wanted to know between this is 1 standard deviation and 2 standard deviations, well, it would, oops, not this part. It would just be literally the sum of those two, yes? And if you want to know from here all the way to there, you just plus all that together, yes? And for him, it worked. For me, I'm too lazy. So I just go 68, 95, 99.7, and off to the races we go. Okay, it's a little minus, a little divide by 2 action, and you're good to go. Dress sizes in the U.S. Made that up. I have no idea. Average is, pulling a number out of my butt, 10. Good for you. I don't know. I just made that up. Standard deviation is 1.6. I don't even know what that means. Honest to God, don't care what that means. Here we go. Let's draw it out. Whee! 10. Bam. 11.6. There you go. 13.2. 14.8. We're gooch. Going this way. 8.4. 6.8. 5.2. You with me? Hey, what's the probability or what proportion of women, by the way, you can say it either way, if you put all the U.S. women in a hat, their names that is, not them personally, because that'd be a large hat, and you reach in and you draw out a name, what's the probability that gal wears between a 14 and a 16 or whatever it happens to be? I don't know. I just made this data up. And you're like, well, whatever, right? Now, Mr. Groom says, hey, listen, either what's the probability or what proportion of them or what percent of them. I think I've said it in this class. If I haven't yet, I'm going to say it today. Percent, proportion, probability. Probability. Potato, potato, vodka. Yes, they are all the same. So when I see this, if I say, hey, what's the probability that a gal wears between an 8.4 size dress? Groom, that's not even a thing. I don't care. Just go with me. And a 13.2. You're like, oh, well, what am I going to do? Okay, well, hang on. So from here to here is 68%, yes? I need to get over here, baby. Now on that previous page, we could look it up. And we know this happens to be 13.5%, so 81.5% is our answer. You could do that. You could do that. You could also go, hey, listen, let's do this again. 95 minus 68 is 27. 27 divided by 2 is 13.5. There it is. There's your 13.5. So remember, we did from here to here would be 95%. We got rid of the middle and then divide the rest of it by 2. So we got this guy plus this. So it's 81.5% of the women wear between a size 8.4 and a size 13.2. Again, doesn't make sense, but don't overthink it. Someone might say, Grim, that's ridiculous. Can you do another one? I'd love to. IQ scores. Bam. Average 90. Just pulled that out of my butt. Don't know. This is true somewhere in the world, I am sure. 13. Sweet. What's the probability or what proportion of people score between a 77 and 90? And you're like, well, I don't know. Let's find out. Here's 90. 77 has a z-score, because that's what we're really doing. We're saying how many deviations is it? 77 minus 90 divided by 13 is -1. So right here, we want to know this. And you're like, well, Groom, that's half of 68. So that's right, 34%. Piece of cake, baby. Piece of cake. So clearly you can be making this guy here into a z-score, which I've already said. Now, someone might very well say to me, Groom, if it was from 70? Uh-oh. 70 minus 90 is negative 20 divided by 13 is negative 1.53. Well, Groom, how many people are within negative 1.5 standard deviations of the mean like that? And the answer is, we don't know yet. But coming up in chapter 6, bro, when we get into the normal distribution, which is the symmetric one that we're going to spend most of our time discussing, we'll learn how to do that for any of them. 0.2, like a z-score of 0.2 or 1.7 or 9. Of course, the answer is 9. By the way, listen, I'm going to tell you right now, friend, if you get a z-score that is, I'm going to say it this way, if the absolute value of your z-score is greater than 2, you are a freak. If the absolute value of your z-score is greater than 3, you are a hardcore freak. Okay? What's the probability that, in other words, what this says is, what's the probability that z is bigger than 3? And the answer is pretty darn small. You with me? There's almost nobody out there. Okay? What's the probability that z is greater than 9? Basically 0. Okay. Now we watch those shows like I don't watch them, but people watch these shows like The Greatest Loser, right? Why? Because the guy weighs 7,000 pounds, and every week he's like, "Oh, I didn't lose much this week. I only lost 50 pounds." And you're like, and some of you are like, "Good Lord, Groom, that's half my body weight." I'm like, "Yeah, I know." Even for you, Groom, that's only like, it's less. It's about somewhere between 20 and 25% of your body weight, right? And you're like, wow, yeah, okay, great. So you're like, oh, that's a lot. Yeah, but for that dude, it's like 0.00001 of his body weight, right? But yet the average dude in America, the average American male, adult, average is probably 220 or something. I don't know. I just pulled that out of my hat, so don't ask where that came from. The standard deviation might be 50 pounds. That's a lot. But what's probably over 7? Well, listen, if it was that z-score guy, if he weighed 700 pounds minus 250 pounds, let's even say, divided by 50, that comes out to be 700 minus 250, I said, divided by 50 is 9. Look at that, 9 deviations. Bro, look where you would be. Remember, there's 3. That's where the freaks are. Like 4. Like, how much room is there left here? None, basically. 4, 5, 6, 7, 8, 9. You're that way. How many people? What percent of the population is out here? This is basically 0 above 3. Then what's it for 4? 5, 6, 7, 8, 9, 10. They're even smaller versions of 0. Are you with me? It's a big deal. Okay, now the empirical rule, again, is easy. It's 68, 95, 99.7. That part's easy. Just figured out. But now you're like, Groom, what if, hypothetically, come on, you hippie, get out of the way. What if, hypothetically, your distribution was not symmetric? What if it looked more like, I don't know, this guy, blue, which is skewed to the right? Okay? Okay, well, this guy is a Russian feller. No, not Putin. No, not Putin. A guy by the name of Chebyshev came along, and he said, listen, we can't say for as much certainty as we can with symmetric, because obviously there's some weirdness. There's some weirdness going on here. We cannot say with as much certainty what percent will be between where and where. But what we can do is this. My boy Chebyshev said, listen, at least 1 minus 1 over k squared times 100% of the population is within k standard deviations of the mean. What do I mean by that? Well, listen. First of all, k has to be bigger than 1. If k was 1, what percent are within 1 deviation? Well, at least 0%. So at least 0% of our population is within 1 standard deviation of the mean. That's not helping me, bud. That is not helping me. What if it was 1.2? So for instance, suppose I told you the mean was 20. The standard deviation was 6. What's the probability that you are between well, we'll do 2 first. Between 8 and 32. Okay. Well, if you make a z-score, z is equal to negative 8. Or, sorry, it's not negative. It's 8 minus 20 divided by 6, which is negative 2. And z is equal to 32 minus 20 divided by 6, which is positive 2. Okay? Now, the formula says 1 minus 1 over 2 squared times a honey. This is 1/4. 1 minus 1/4 is 3/4, which is 0.75. Times 100 is 75%. What Chebyshev says is at least 75% of the population would be within 2 standard deviations of the mean. But Groom, I thought it was 95. Well, it is, dude, for symmetric distributions. But last I checked, 95 falls into the at least 75 category. Are you with me? So when it's symmetric, it is 68, 95, 99.7. When it is not symmetric, we're going to have to use Chebyshev. Now, Chebyshev is cool because, oops, a guy can do something like this. Watch this. Watch it. Watch what I'm doing. Ugh. What did I just do? So let's make z-scores. So z is equal to 12.8 minus 20 over 6, which comes out to be negative 7.2 over 6, which is negative 1.2. 27.2 minus 20 over 6 is also 1.2. So Chebyshev would say this is equal to, I don't know, so let's find out. Oh, Betsy. So at least 31%. At least 31% are within 1.2 standard deviations of the mean. Again, the further out I go, the better we are, yes? Now look at this problem here. Look at it. Look at it. What if I change it and said, what's the probability that you are greater than 27.2? Okay, in that case, you're like, Groom, okay, listen, we just did this, Groom, or whatever. Here is your 31%. What percent's on the outside of that? 69%, and then 69% divided by 2 is 34.5%. At least 34.5% is up there. Okay, that's the idea. Okay, probably won't ask that one too many of those ones. We typically, with Chebyshev, stay on the inside. Okay, that is, again, Chebyshev and the empirical rule. All right, cool, bye.